Hello viewers, welcome back to another section of my calculus tutorial, and in this video we are going to solve limit problems. If this is your first time visiting this channel, kindly subscribe and you will like the video. Please watch the video to the end so that you understand every portion of the video. So let's take our first question. It's saying now find the limits of the function 1 over the expression x minus 3 all squared as x approaches 3. Then the second question is find the limits of absolute of x over x as x approaches 0. Considering our first one, when you say limit of a function, so if you have a function as you have at this, and you are being asked to find the limits as s approaches a particular point, you can approach s equals 3 two different ways on our plane. On the x-axis, we have the negative side and we have the positive side. So I can approach the 3 from this side or this side. Wherever I approach it, the limit rule is saying that I should get the same result. If it happens that I get different results, then it means the limit doesn't exist. Also, in limits, if you solve a limit and you get an expression 1 over 0, the answer is equal to infinity. It is not undefined. Take note. Take note of this. In limits, if you get, after putting the limit value inside our function and you happen to get 1 over 0, the answer gives us infinity, not undefined. This is a very important concept you should understand. Generally, mathematics, 1 over 0 is undefined. But if you find the limit as a function approaches a particular point, and it happens you get a function, you get a resulting value as this, then your function is going to be equal to infinity. So let's see our first question. As s approaches 3 here, straight away, the only thing, you see, we can't simplify this anyway. Normally, if they give you a function, you first have to simplify it to eliminate any form of or any way that's going to cause you to get undefined. Let me tag it that way. But in this case, 1 over x minus 3 all squared, you can't simplify it anyway. So you have no option except to put your functional value 3 inside. So I'm going to get 1 over 3 minus 3 all squared. And that is going to give me 1 over 0, which is equal to what? Infinity. So take note of it. The answer is infinity. So as we're approaching 3, the function doesn't end. Let's go to our second problem. So the second problem is absolute of x over x. As x approaches 0, we have our limit here. So now, you know absolutes, if you put positive, you will still get positive. If you put negative, you still get negative. Sorry, you still get positive. Absolutes, whatever input you put here, you're going to get positive solution. So let's see something here. In this function we are having here, you have been told to find the limit as this approaches 0. First of all, if I put 0 here and I put 0 here, I'm going to get what? 0 over 0. This is what we call indeterminate limits. Indeterminate limit. Remember that any number by itself is 1. Do you mean that 0 over 0 will be 1? You can't tell. So you see it's indeterminate. The next thing to do is make sure that we simplify this expression so that we can be able to get what? The limits. Can we simplify this? Let's try. Now, if you want to approach 0, you can approach it from the left side and from the right side. So let's see. The absolute sign can give us two different parts of this function. I can get negative x over x, and I can get positive x over x. These two are the separate function I can get from this. If I approach this function from the left side, I'm going to expect this function. If I approach the same function from the right side, I'm going to get this. So, finding the left limit 0 minus, I'm going to get this function in play, the negative x over x. So therefore, x will cancel x, I'm going to get what? Negative 1. Remember, limits of every constant function is equal to what? the function itself. If you have f of x is equal to 2 and you find the limit as s approaches any number, the answer will give us 2. So from here, since we have negative 1 here, the limit as s approaches 0 is still negative 1. This place will simplify to give us positive 1. So the limit as s approaches 0 will also give us positive 1. We will realize that the right limit 0 minus and 0 plus, the left and the right are not the same. Therefore, the limit does not exist. The limit does not exist. There is a discontinuity between the two. It's two separate parts because one part is giving us negative 1, other part is giving us positive 1. Thank you for watching the video. Come subscribe and also share so that you get updated for any new tutorial I put on.